Okay, I did my presentation on database security. And to start off with, just look at the database systems that we're going to be looking at. I chose the Oracle database Enterprise Edition and the MySQL database server. Assuming both of them are running on some kind of Unix-like operating system, because usually that's where a production database will be run on. Okay, some of the pros for the Oracle database. It's the most widely used enterprise database. It's very powerful. You can do pretty much whatever you want with it. It's very stable. You're not going to have very many like read or write errors. And the database can be as large as you want it to be. You can cluster as many servers as you want together. And it's been around for over 30 years. Some of the cons is that it's extremely expensive. I know the USG has a license to put Oracle for any institution as much as they want, and I'm sure it's millions and millions of dollars. It's very difficult to maintain. You can't just put someone on if they don't know anything about it. And because it has all of like the different protections and such, it's a little bit slower to access than some other databases. And MySQL is the open source database, or it's one of them. It's really widely used on the World Wide Web, and Facebook uses it for like wall posts and friends and such. It's designed to be very quick at reading and writing. And it's also easy to administer. And it can be used in more advanced situations, such as Facebook. It's as other database management systems out of the box anyway. And it has limited scalability, unless you do like Facebook and just modify it pretty heavily. So the main areas for concern are the actual database server and the files that are on it. You also want to be concerned about the network packets going in and out, making sure they're secured, and also user accounts. Okay, yeah, the main points is that the data files must be kept secure. If someone has the data files, they have your database. So. And you want to make sure that as few users have access to the operating system as possible. And of course, along that goes firewalls need to be set up and properly maintained. Okay, so the key Oracle database files are the control file, which it contains the database name and the locations of all the database files. There's obviously a lot more to it than that, but that's the main things we're concerned about. And then there's the database files, which contain everything in the database. MySQL pretty much just has these FRM files, which holds the table definitions, and then MYD files, which hold the actual data, and MYI files, which hold indexes created from the tables to make it easier to search through. By default, data files are stored unencrypted for both systems. Oracle has transparent data encryption built in that you can configure if you want to. But MySQL has no encryption out of the box. You have to just download. There's open source solutions that you can implement for that. But as with encrypting anything, you have to make sure you keep the key safe, because if you don't have the key, then you can't get in. Okay, if an OS user has the right permissions, they have full control over the database. So for instance, Oracle, if you're a member of the DBA group, you can just log in as sysdba, and no one will know. You don't have to put in a password or anything like that. And on MySQL, there's a root user it's actually a database user, but you can reset it from the operating system. But if you do, you have to require a restart, so it's pretty easy to detect if someone does that. You should have 2 levels of firewall protection. Obviously, the network firewall on just for the institution should keep all outside data out, and you can also use it to help keep inside data off the server as well. But you should also have an operating system firewall to just limit, only the IP addresses that you want to be able to log into the server, just in case something happens outside firewall or anything like that. And you should make sure that only the database connection ports are open. You want to try to avoid putting any web servers or anything actually on the database server. Okay, so there's pretty much always going to be backups that exist of a database. The more critical the database, there are possibly higher number of backups that exist. And most places will have off-site backups, just in case there's a fire or a tornado or something. And if someone gets a hold of those backups, then they can just create a new database and load your data into it. So this is a backup scheme for probably like a medium-sized business. They're going to keep some backups on the actual database server just so that they're quick and easy to get to if they need to. And they'll also they may keep a copy on another server in the same data center because it's also fairly quick to get to. They'll usually have some sort of either tape backup or some kind of system like that, and they'll take that off-site. And it's possible that maybe their DBA will keep an external hard drive that has a copy on it and just keep it at his house or something. So if anyone can get to the backup on the actual database server, then they're already on there, so it doesn't matter. But if you're keeping a backup on a different server, you want to make sure that you have security just as tight. And you want to make sure that if other users have access to that server, that they're kept in a folder where no one else can get to. And this make sure it has root access to everything, because they shouldn't. Just be careful about that. So if you have it on backup tapes, tapes can obviously be stolen. But the attacker would need a tape drive to read everything. So if it's just someone that broke into your car looking for money, they're not really going to do anything with it. But you should definitely keep them in some sort of a vault or safe, and make sure the tape drive supports encryption. And the same pretty much goes with just a hard drive. Either one with they have like passcodes on them or a fingerprint or something. Log into them. If someone does get the backup, all you need to do is install a new instance of Oracle and create a database with the same name and create the file structure that's in the control file, and then they can just load up the new database. For a MySQL database, you just have to, if you have the actual backup files, then all you have to do is just copy them into the database folder, and you can get to the data. But sometimes for MySQL backups, you just run an export, and that just creates a .sql script. And you can just run that script and recreate everything. Neither Oracle nor MySQL are encrypted by default. Oracle has a software called Recovery Manager, and you can set that to encrypt backups. It'll automatically encrypt them and then decrypt them whenever you're reading them back. MySQL doesn't support encrypted backups by default, but since it's open source, you can always just download add-ons, or you can purchase the Enterprise Edition. That's about $5,000. So if it's like a medium-sized business, that's not a big deal, but you wouldn't want to have that. Just spend $5,000 for your personal website. Okay, network security is something that's sometimes overlooked. If it's not secured, then an attacker can just sniff the packets and just see whatever plain text information you're sending to the database. And also, a lot of the times, there will be application servers connected to the database or like web servers and such, that read all of that information is also encrypted. So the database, just by its design, is made to communicate with several different servers. But by default, those communications aren't encrypted. So you'll have to, So you have to turn that on yourself. Oracle supports a pretty wide array of encryption algorithms. I think last I saw they were suggesting the RC4 256 for speed, but I think it's relatively easy to crack compared to things like AES. And MySQL, depending on what version you download, it may or may not come with encryption built in, but if it doesn't, it's pretty easy to set up to run OpenSSL. So it's really important to make sure that the traffic from the web server to the client is encrypted. Because some database applications, it's not good practice, but they will store plain text, username and passwords in a table in the database. And while that's not exactly breaking into the database, it's you can still get a lot of sensitive data. Okay, so again, user accounts is probably the easiest way to get unauthorized access to a database. People can be really lazy with their passwords. If you let them, they'll just make it password or 1234, and write it down somewhere. And as an administrator, it's also kind of easy to just say, all right, well, I'll just give this person all these permissions, and so they won't bother me again if they need access to something. Obviously, weak passwords are a huge threat. So you should implement some kind of password policies where they make, just have certain minimum requirements. By default, MySQL doesn't come with anything like that, so you can either create your own or just download one and install it. And the Oracle password policy tool is actually pretty advanced. There's a screenshot. So you can select minimum length, maximum length, repeated characters, disallow user ID. It's pretty, you can make it as complicated as you want to, pretty much. So this is just a password policy that seems really secure. Say, it must be 10 characters long, have one uppercase, one lowercase letter, one number, one special character. You can't let the username be the password, and say it expires every 60 days, and people can't reuse their old passwords. that's very secure from like a brute force type standpoint. But as you can see, it's really annoying to have to deal with. So that's where if the passwords are too complicated, people are just going to start writing them down and keeping them under their keyboard or wherever, or just keep them in a text file on a desktop. So, and I don't know if anyone's had to deal with, especially people that don't like to use computers for their job. They're usually the first ones to do stuff like that. So you'll want to use like a pretty reasonable password policy. One it's secure, but still, it's not going to make people just write everything down or whatnot. Password safes are really good. You have one master key to get into the password safe, and then all your passwords are encrypted in there. Some examples are like LastPass and KeePass. I use LastPass. It works pretty well. It's web-based, so it just has a browser plugin. As far as like database session length, I know in lecture it talked about determining a session length and just saying like the session ends at lunchtime or something, and then you have to redo it. But for database sessions, you only want them active if they're being used. Because obviously, unlocked computers open to attack. If someone, walks away for, a meeting for 30 minutes and forgets to lock their computer, then they can get on the database. So you should make sure that the timeouts are set. Probably 5 minutes or so is a pretty good one, depending on what you're doing. Okay, and keeping user privileges restricted is pretty important. Like I said before, it's easy to just give people blanket permissions to have access to tables and processes they don't need just in case they need them someday, so they don't call and bother you. But as soon as you start doing that, if someone that doesn't know what they're doing just gives someone their password or something, then it can mean big trouble. Database write access should be protected. If gets mad, quits, you don't want them going through and just deleting everything from the database they can, making you have trouble of doing a. There are several default accounts that are used when you install the database, and you should make sure that those passwords are locked if possible, or just expire the passwords. So for Oracle, that's like the system account and sysaux, because they come with really weak default passwords, and you can do anything with those accounts. MySQL, that has, like I said, the root user, it's probably best if you have that to where you're allowed to only locally log into it from the operating system, or at least just have a very secure password. And a lot of the times if you install other applications, they will use like their own username to create tables and run permissions and such. You need to make sure that after you've installed any applications, those accounts are also locked. And you'll want to use a little more restricted accounts to actually access those programs. Okay, so just an overview. That's the main things to be concerned about are the server security and the network security and the user security. All the different database systems handle that differently, but you'll want to generally apply the same principles to each one. Any questions? Anything?
What about SQL injection?
Okay, yeah, the SQL injection is where it's usually if, like, the web server isn't the input, a web server that interfaces with the database. A lot of the times the web server sends SQL code to the database to get information or to log users in and such. If they if the website isn't, like, the input isn't sanitized where it doesn't allow you to type in certain things, you can just go in the URL and have the URL in and then just type in select star from users, and that'll just give you a list of everyone of every user on the database, or you can get into passwords and stuff. If you know the actual tables of the database, then you could use that to just pull the information directly. It's yeah, that's also a pretty big problem.
What kind of thing?
What's that?
How can you protect?
Usually you'll want to make it so that, like, so that you can't just type in, like, whatever, like, select statements or update statements or anything in with the forms. I don't really know a ton about SQL injection because I guess I thought that's more like a website thing.